Very good morning, everyone. Welcome to this design studio track. And we'll start by explaining how we implement ML in positive technologies.
Да, здесь, значит, история про...
Okay, so here's the QR code that you can scan and become a member of our secure development community. You're welcome to join. And now a few words about us. As I explained, we'll talk about how we implement ML at Positive Technologies. I'm Nikolai. I'm being joined by Artyom. I'm a team lead at Positive Technologies, and we develop ML. Artyom is also an ML engineer. He does very cool things. He does analytics. And we wanted to talk to you today. Is it possible to do without ML? The presentation is about how we implement ML, but maybe you don't need any ML altogether. We'll talk about how our process is structured, what we use. We want to talk about a number of use cases to talk about how ML fits. And we'll talk about a couple of practical examples. Let's start by talking how or where ML comes in and what data we work with. Let me give you a high-level overview of how cybersecurity products work. So suppose we have raw data. That could be data logs, that could be traffic. Those could be executable files. To do analytics, we need to structure them. We analyze the data, we parse them. We structure them. There could be some JSON or CSV structure. And then with this structured data, we can do heuristics and detect attacks. But even after the detection, we want to describe an incident, because obviously not all attacks lead to issues in operations. And once we've detected that, we want to do an investigation, and this is what our team and other teams do. After these automations, the results of that, as I said, are rules and heuristics. But we've got to have a broader view, because a hit might lead to various consequences. There are dashboards that people look at and take measures. So ML can be used at each of these steps. And why? Because data is everywhere. And where there's data, you can use ML. When we convert the data from raw to structured, we can address issues such as gap filling. Some data may be missing. We might use ML to generalize and look for zero-day attacks, the attacks that went undetected previously. And in transitioning from hits to incidents, when an operator has hundreds of hits and they don't understand what's going on, it would be good to group the data to show some top importance lines. And again, clustering works very well here. A few words then about what we work with. There's a short link here, and I suggest that you follow it now. The top participants who follow the link and decipher which is what will get the prizes. We asked our model to give a picture of what it thinks about the products that we use. And we have 4 products. That's NAT, Network Attack Discovery, CM, Sandbox, and Application Firewall. And you just have to map which is which. I hope that you were able to click this link, and then we'll continue. Okay, and very briefly, the link would take you to our chat, and you're welcome to map the pictures to the numbers, and the first who answers correctly will get a prize. We'll tell you later where and how you can get it. Thank you. A few words about why we need ML. There's the classic approach, and it works well. Attacks are detected. Life is good. So what do we want? We want to make our products run on autopilot. Why? Because we want to automate routine operations of operators to identify, detect new attacks, and to raise our expertise that underlies every product, because without it, there is no logic, there can be no detect. Expertise drives it all. I will now give you a brief overview of what tasks, what problems we come across. And I would group them into 3 buckets. That would be expert assistance, detect, and operator automation. Again, I want to say this again, that we implement our expertise in our products. We detect attacks, and at a later stage, when an operator looks at dashboards, there could be some automation based on data analysis. For the benefits of the experts, we now show a number of examples, and I will talk about a generalization of a rule-based approach in an application firewall. And the idea is as follows. There's a firewall with a certain business logic. There's a certain approach. There are detects in place. So what if we take a model and solve a classification problem? And as a supervised approach, we would use the labeling in the firewall. So by doing that, we'll be able not just to identify new bypasses, but we'll be able to increase the comprehensiveness of the model. We could detect certain errors, and we could see, for example, that a model finds something that an algorithm was not able to find, and this could be brought to the attention of an expert. And we did a study on the last year's standoff data, and where we implemented many bugs, many features that the guys were able to fix. And so this shows us that this approach works. Another case is when we do a detect, and here we enumerate some options, and not all of them. This is not an exhaustive list. Okay, web shells, I'll talk about that. Meta exploits, I think we talked about that previously. Behavioral analysis of process chains. Artyom will talk more about that. Behavior analysis in a sandbox, we talked about that yesterday at the AI track. And NAD, malware detection and encrypted traffic, we also presented yesterday. So this is more or less a complete overview. So let's move on then. And this is an example of what I talked about shells. Okay, so we load some payloads, we get requests through HTTP, and there might be an issue somewhere, and we can solve the problem of binary classification. We can analyze the text of the request, the headers, the payload. Clearly, the payload may not always be machine readable. It could be in raw data, it could be in some other non-human readable format. Here's what we did. We took data from GitHub of different shells, and we also used our proprietary shells, and we built models to detect those shells. We started from some baseline, such as logreg. Then we tried to convert that in RNN, and then we ended up with convolutional neural networks because they showed better performance, including in terms of false positives. We were able to detect some new attacks that a rule-based approach was not able to find. And again, based on last year's standoff, we took the traffic, we extracted the shells, we did our detects, and we had multi-level processes there. There's clear logic. There are rules that would say that, okay, here's in the request you have some malicious call, and there is some fuzzy hash approach, and there's an ML at the end of this chain. And it turned out that we are detecting with the same low level of false positives, but plus 30% of shells. And this is an example of a shell that's loaded into a PDF. And apparently, we won't be able to find much with a rule-based approach here, but we can with ML. And the third class of problems is when we try to help the operator. And this is an example of how we try to find among many hits in a particular system, such as AF, for example, to find something exciting, to do threat hunting, to find some meaningful events. Say if there's an attack and we want to find attacks that are similar to this one. And for an ML algorithm, this is a lot of potential for implementation. Proximity metrics and other methods can be used. You can do grouping. You can do clustering, as I explained. You can join those hits together. You can try and identify a typical representative within a cluster. And we might end up by saying, okay, why don't you, rather than looking at all hits, you might look for just one hit, because it is a generalization of most others. And if we were to generalize on those three use cases, the detect, the operator support, and one other, it turns out that there's behavior analytics in CM that Artyom will talk more about. Yes, so in CM we have a behavioral analysis module, and it covers all of these three product aspects that Nikolai talked about previously. So what's the idea of behavioral analysis in SCM? The goal of behavioral analysis is to identify users who are perpetrators, adversaries, and we use that by assigning risk scores to users. And here's how we do that. Initially, we have a zoo of low-level models. Some of them are ML models, others just statistical approach models. But the problem is that individual hits, individual anomalies cannot be mapped to particular attack types. So a hit doesn't mean 100% that there's an attack, and it works the other way around as well. So rather than use direct correlation that a hit in a model means an attack, we build a vector of a process, and the vector is comprised of responses of the models, outputs of the models. And then we use our service, a profiler not for the development, but in the sense that we develop a profile of a user. And it can use two approaches. So it could be a rule-based approach that we get from the experts. Experts use additional sources for correlation and build their rules based on that. Or in the future, we want to apply ML on top of that to have an even higher level solution. And after we apply certain number of scores or points to particular processes, we know that a process is executed by a user. So using very straightforward aggregation, you can get a sum of points or scores for every user and rank them and see which users are the highest on the radar. Under the hood, in this model, we have a number of exciting solutions that use ML and data-driven approach. And these two models are recommendation system on processes and a model on process chains. So the recommendation system works as follows. As we know, recommendation systems are often used in production to recommend to users certain products or certain goods. We don't recommend that. We recommend processes, and the processes match to certain software. Let's take an example. If we have a programmer called Oleg, and he uses certain codes, it's fine. But at some point, his colleagues come to him and tells him, "Why don't you use another approach?" And he thinks, "Why don't I?" Indeed. And at that point in time, the programmer launches a new process. And what happens in this situation? Can we believe that a new process that he never used before is an anomaly? If we used a simpler approach based on tables and lists, we would have thought that's an anomaly, whereas that's a clear false positive. Or let's take another situation. There's an accountant by the name of Valentina who at some point rather than launching MS Office or 1C, she launched a QMI.exe. Now that is strange. And given that CM receives a lot of data about user activity, including on process launches, we can build a matrix of interaction between users and processes, and based on that to train the model for collaborative filtration, so that every user at each particular point was recommended the processes that they would legitimately launch. And so that is the basis of process recommendations. And we liked the outcome of model training. If we reduce the dimensionality of vectors of our users, then on a surface, the users with similar job descriptions, you can see that they cluster quite well together. They group nicely. But how do we then identify anomalies in this situation? Imagine that for every user, there's a recommended set of processes, and they launch processes at a certain time. If there's a match, there's high quality, low error. But if the quality of our model starts declining at a particular user, so the metrics of time series start deteriorating, as you can see in the slide, we can register anomalies and come up with outputs. So that's our recommendation system. There's another model which is based on process chains. Initially, in process chain analysis, we looked at the chain taken together, but this is not very useful because chains could be different, the lengths could be different, length could be different, and it's difficult to come up with an integral data set. So we decided to split this chain, as the slide shows, from A to E, into pairs, AE up to DE, as you can see in the slide. By forming these shorter pairs that always end in the most recent sibling and starts with intermediate components, we can build a correlation matrix in which every cell corresponds to these cells, A, E, B, E, etc. Once we get data from the CM, we look at whether there have ever been a transition from process A to process E. We count the number of such transitions, and we get the probability of such a pair happening. If there hasn't been such a pair, so we can treat this as an anomaly. And let's take a simpler example. There's this chain at the bottom, Outlook, Word, CMD, who am I? And you can see that a transition from CMD to who am I is not something that is suspicious. But if there is a transition from Outlook to who am I, that is suspicious and can be reported. A few words about the structure of behavioral analysis. As you can see, it consists of 4 branches: collector, responder, a trainer, and inferencer. Initially, we get all the data from CM through a queue, and we clean this data with a collector and put it into our internal database. Thereafter, we go to the model stage, and in the behavior analysis service, we have a self-served model. We have online models, and we have pre-trained offline models. And the training of the models is done by the trainer service. It would use a schedule to upload data, or download data from the database. The models would be trained and updated. The inference and the learning about users, that is the inference branch. It queries our zoo and sends information to the database. All the information that CM needs, it can get through an API, through a responder, and we can get various metrics. We can score a process, or we can score a user or a task. And what is it that we are looking for? The attacks that we are covering are shown here in the slide, but importantly, the behavior analytics module is not exclusive to detect a hacker on those vulnerabilities. After all, CM can also do that. It can detect some of these attacks.
But the behavior analysis can do what CM cannot do. The first case is when we have a lot of alerts from CM, a lot of correlations, and it's difficult for the operator to realize which alert has to be acted in the first place. Our approach reduces the workload on the operator. The second case is when CM didn't detect a certain attack, and our analysis gives you additional information for further operations. So far, with our behavioral analysis, this is the way we look like. This is the way we feel. So we have 3 pillars: mathematics, algorithms, and computer science. The matrix structure of the company makes it possible to build virtual teams for each product or area. We have experts of security center, security experts. They can tell us about each type of attack, what kind of approaches can be used. Then computer science, that is development, mathematics, that's us, the engineers. As you can see here, we are responsible not only for mathematics, but for other things as well. What is our pipeline? We start with the problem. We get a problem, and any person can arrive, can come to us, a person from our department, a top manager, whoever, and he will say, and let us do this. And we say, why not? We have ML lead, we have experts, expert leads, we discuss the problem, and we develop the mission. After that, we implement the mission. We include ML engineers, security experts, and we start working together. We use default stack of data science. If it's all right, we go to the MVP stage. Developers are involved here. We go from Jupyter to full-scale project. We developed the code, which is close to production. After we look at the results of how our model is working. We get in touch with experts, trying to raise the quality, reduce the number of false positives. If MVP is successful, then we go to prod. However, if the results are not satisfactory, we can roll back. When we go to production, we also include developers of the products, CM, for instance. We are talking about integration, performance, and monitoring. Monitoring helps us to boost our expertise and solve other problems, for example, performance. At each stage, we have best practices. Sometimes they're used by default, code reviews. For data science, we use versioning of experiments. So that's it. Each developer has his own libraries, and for versions to be not vague, we have certain templates, because if you look at somebody's code and if you do the review, if the folder is called differently, it's very difficult to realize what is happening. So template is necessary. Template is good. One project template, so that a new person who comes in and makes a review should clearly realize what is happening in the code. So what kind of limitations do we have in our domain, and how we use it? So what do we do in this area? Next slide, please. We are trained all the time. That is good. Unfortunately, due to the fact that we have box products, it's difficult to do inference on GPU. We use CPU, and I will tell you about the limitations. It's the detect time limitation, inference time limitation, depending on the type of the product. For example, in the blocking, you have to take decision very fast, or if you take CM or Sandbox, in Sandbox you can launch a file, it's executed, and the analysis takes minutes. So there is no need to take a decision within seconds. We can take a heavy model and carry out high-quality detect as a result. Another limitation is about quality. We want to develop high-quality products in an automatic way. If the system works in a bad way, nobody is going to use it. So the quality of model should be very high. It means that, well, we make a model, we validate it, 0.99999 accuracy, but when you look at the real world, at the huge flows of events, millions of events, then 0.99999 means that you will get 100,000 alerts. And it's impossible to clear up the mess, and we try to reduce the number of false positives as much as possible, but we shall always have them. So the question is how many of them or how few of them we're going to have. There is nothing strange here. In ML, it's important to realize what is happening because it's the people who use the products. The expert comes and says, why 0.0, why malware, why 0.9, why this anomaly. And of course, you can show him metrics or just raise your eyebrows, but you have to explain to ML user how and why such and such algorithm operates. Another thing is implementation of the model. We have three options. We already mentioned them. We can deal with self-service, with preliminary trained models if the data set doesn't change in time. For example, if you take shells, the growth in time is not big, and we can make one model for one specific language and say that we know 98% of shells and we're going to work with them. And as soon as new ones appear, we're going to retrain the model. Another thing is that when we can prepare a model as a service for our internal things, not for external ones, we can help our security analysts for different services. And of course, we can use self-services. We can be trained on customer data online. Of course, we, because of our specifics of our domain, we cannot involve some specialists and get nice pictures, because each attack, each event requires a lot of efforts to realize what is actually happening from ML. Experts can help. Well, fortunately, sometimes we use approaches based on clustering or classification. No one can do anything about it. How can we implement all that? The most interesting thing, nothing superficial, nothing. So we work in the cubes world, Docker composers. We can share data, we can share services, we can distinguish zones of responsibilities. But it's interesting when we integrate our solutions in the product. For example, we have repositories with Python, product repository with C++, and some others. How can we merge all that? We can do it through CI/CD. We train the model on GPU ourselves. It goes to Artifactory. From there, we download the artifact, pack it in the low interfaces, and publish ROC packets. And the C++ repository takes them and uses them as a native application. Another option is to integrate into the sandbox. We have Python code, we have models, we serialize it through NX, we use MLflow for tracking events and for artifact storage. The peculiarity is that we have a daily flow of events to test the quality of the model. And there is also a template set with no faults at all, and the trained model gets into the product. So we have MVP, POCs. We integrated it in the product. It seems all right. But the process doesn't end here. We have to monitor what is happening there. How do we facilitate our life there? We place the high level of requirements to detect a lot of nines after 0. We install our ML solutions and test them inside the company. And of course, we collect telemetric data. What do we have as a result? So we seem to strive for ML plus Interfact to love each other. So we raise the completeness of ML, the comprehensiveness of ML. We try to work in an automatic mode, but we shall always have false positives. The matter is the task is to reduce the number of false positives. We have certain limitations. We cannot reduce them to 0, and we just have to learn to work with those false positives. That seems to be all. Please vote for our presentation through this QR code. Write to me or to Artyom, to Telegram, and also you can have a look at our team in Positive Technologies. I invite all of you to the interesting presentations at the Python section, where we're going to tell you about helping our security analysts. It's also about ML. Use the links, vote. Thank you. So we have some time for Q&A. Ask your questions, please. Good morning, colleagues. Thank you for an excellent presentation. The question is like this: how do you verify the fact that ML is not poisoned, that it gives you correct answers? So, in fact, you push responsibility for the incident to machine learning. But how can you be sure that ML works correctly? And what? How can we make sure that ML works correctly? There are 2 points. How can you poison the ML model? We can do it on purpose or casually. So HR prevents the people who can do it on purpose. But sometimes we have a pen test. We have data. The data is downloaded into our trained set. If data is corrupted, the corrupt data goes to the model, and then ML wouldn't be possible to detect. So we have feedback. We have feedback to avoid that. So the data is going to be detected and deleted from the data set. So this is what we do. Well, thank you very much for the presentation. I would like to add to the previous question. There are other attacks apart from data poisoning. It's an active area, ML. It's introduced everywhere. There are some attacks which do not require data corruption. If you will look at the model if it looks like a black box, you still can attack it. It's an important question. The model, as it is, of course, is sensitive for your enterprise. We use the model in the product. And what shall we do? What kind of guarantees we can offer? Do you take into account such threats? Well, the threats of data leaks or model corruption. What kind of threats? Sorry, I have an idea. I cannot hear the question. So, a lot of threats. All right. Now, for example, ChatGPT, engineering, malicious prompt from user to us. Well, I think we protect our model at the stage of integration of who is going to use it and how. If we do it as native integration in product, the product cannot address the model. If we look at self-service implementation, model as a service, model as a service, we do it for our internal users. And we presume that we don't have malicious persons inside the company among our employees. So that's it. Hello. As far as I understood, you built it from scratch with your own hands. What about building a database of such processes? And then you can take a transformer and train the transformer on that database. No, actually, we have a lot of ideas, and this idea has always also been regarded, but I can tell you for sure there is another implementation. We call it dangerous chains. Oh, sorry. Let me show you how it works. For example, we have a chain from Outlook to Who Am I? We took a lot of chains, tagged chains. We know which one is malicious, which is not. And instead of using the names of the chains, we changed the names to masks by category. Outlook means mail users, Excel, PowerPoint, Office package, and so on. And by using such mask names, we trained the model. With a trainer, and we have it. It's part of our model in production. Thank you. Thank you. May I ask one more question? And such chains, are they useful to cybersecurity specialists? Did they enable development of certain rules or policies, or is it just a tool for additional analysis? It's hard to say when I speak about experts. Is it just an additional tool to get more information? Yes, they are used for confirmation. Let me give you more context. Sometimes we solve problems. An expert comes with a problem, we do something, and it turns out that we can solve the problem without ML, and it's all right. And the people can write some heuristic approaches, some magic numbers, without ML, on the basis of sheer data science, find some laws. And we had such cases before. Thank you for your presentation. Coming back to secure development, I have two questions. Are there any mechanism, any engines to ensure security of model development? And second, are you going to install ML to Application Inspector and other secure development tools? Second question, we don't have such plans now, but first question, security of ML. I told you about CM, and the answer may be somewhere here. When we inside deploy some models, those models go from one box to another. At the stage of model training, at a certain work in CI, we look at the quality of the model, we look at how the quality grows and make conclusions. But that's about ML, and how do we protect the model itself. And here, Artyom already told us about different types of implementation, deployment. No. For example, we have a code for CA and all that, taking into account of ML, specifics of ML. Is there anything specific to ML? I don't know anything like that. Okay, thank you. It's about inference. It's a limitation, you said. It's imposed by the companies, your customers, or your developers. If the company has some computing resources, then you can give them a heavy model, and as part of CM, well, it's a story about money. Money, of course, there is a product which costs a lot of money, and in order to work faster, we have to add something on top. Currently, not everyone is ready for that. But hypothetically, for the future, it's quite realistic. It may so happen. Apart from hardware cost, you also have to compare risk to expenses category, because sometimes the cost of eliminating the risk may be too high. If you have infrastructure, then it is used already for something. No more questions, then we can choose the best one. Whose question was the best? I liked the question that I couldn't answer about security. I support that, yes. We were deadlocked, so that is the best question here. And the rest, well, what about this link with the picture? Where is it? Oh, yes, here. Please use that link and send your messages to the chat. CM4, this is wrong. Just do the job.